name is Stan Crustle, and today, along with my teammate, Ashton, I'm going to talk about AI-driven nutrition system. The target problem statement you gave us was thalassemia patient suffer in India, has less nutrition deficiencies, risk of high overdose of iron, and which leads to emotional stress. And there are no tools for this. So we propose a solution, a assistant which is very smart, which tracks diets and moods, and gives recommendation based on Indian cuisines or regional preference, and gives multiple language supports. And gives enables doctor to assist them if they need it. The stack we're going to use is front end, React Native framework for animation. Backend I'm going to use Node.js or Python, AI models, GPT or Gemini, and multilingual we're going to use N8N integration, which is an AI tool. The functionality of our website, it gives user logs meals, which means it gives a tailored recommendation, and based on that, it gives preference of their meal. It gives a good suggestion like low iron recipes and other recipes. Give reminders for patients who miss their medicine or if they eat wrong things, and if they give a daily recommendation of what to eat. Also, we have a chatbot which talks with them efficiently and with based on their behavior and everything. And we have doctor portal which they can check there if they want to talk to the doctor.
Hello everyone, this is Ashton, and I'll be guiding you through the impact of a solution. In clinical impact, we have decreased risk of iron overload. So thalassemia being a chronic condition which has risk of iron overload, we wanted to track their meals and recommend them certain meals which have lesser iron intake. For example, we have the database which shows the meals or the cuisines of particular states. So for example, I give Goa, which has fish curry rice as the main staple diet. So we wanted to recommend them certain kind of fish or certain kind of vegetables which they can have, which are found in Goa, which they can take, which have low risk of iron overload. And in the same way, we wanted to enhance levels of micronutrients. So thalassemia patients might have certain deficiencies in these micronutrients based on the recommendation of the doctor as well as their lab reports. We wanted to recommend them certain meals, whichever state they are in those particular cuisines. We wanted to recommend them certain meals which are rich in these micronutrients, so that those deficiencies can be taken care of. So improve adherence to treatment. We wanted to give them reminders throughout the day, like take this particular medicine, and then it will give them a notification on their phone. In behavioral impact, we have healthy emotional coping strategies. So thalassemia being a chronic condition might have different emotional responses. So we wanted to keep an AI assistant that guides them through this journey of healthy eating as well as taking their medicines, so that the treatment, whichever treatment they're taking, can work like properly. So stronger food mood awareness and increase engagement through gamified nudges. So we will give them like if they take the whatever meal we recommend, or they have a good iron intake, so then we can give them like achievements of today, like that kind of stuff. And in community, we wanted to connect people like the caregivers or even doctors with these patients, so that they can monitor the patients. Like doctors, for example, can monitor their patient, their iron intake, their medicine, whether they're taking their medicine properly, whether their mood is like proper, whether they're eating well. Even the family members, we wanted to connect to this, so that both the caregivers and the patients have better like better tracking and better response to the treatment. And scalable for NGO and rural outreach. So in rural areas also, there might be these patients which have they don't have internet access, so they have like poor internet access. So what we wanted to do is make it offline, so that they can run their devices on the edge. So like they have no issues with it, living in even rural areas of the country. And sets a model for cultural context and chronic care. So this model which we are giving, like recommending them certain diets based on whatever they're eating, and giving them behavioral responses, so that this model can be used for other chronic conditions which might have different behavioral responses. The challenges and constraints which we have, data collection for regional mills. So collecting data for each and every state might be not so easy, like, so we wanted, this is one of the challenges that we might run into. And ensuring accuracy in iron recommendation without clinical testing. So recommending, iron particular, like this particular meal has certain kind of iron content, then, ensuring accuracy is there in this without, proper lab testing of that particular meal, like for each and every meal, is not so easy. So that will be one issue which we might run into. Then balancing sensitive emotional interactions to AI. So we'll have to keep the AI in check, whichever the assistant is, so that it does not interact, it doesn't cross any boundaries. And multilingual NLP complexity. So we wanted to also ensure that each and every language of the country is covered. So, but we might run into the problem wherein the NLP, the assistant which is there, might not have that particular language understanding. So that is one of the problems we might run into. The assumptions which we have is the caregivers can log food and mood regularly. So doctors and all, they might be busy. So we assume the doctors can give like some time of the day in tracking the patient, or even some time of the week in tracking the weekly results of the patient. Then we have regional food habits that are relatively consistent and can be mapped to nutrient values. And users will be open to receiving mood-based nudges. So users should be able to communicate with the assistant. Like that is one of the assumptions which we're keeping. And caregivers and doctors will have access and time to use the monitoring dashboards. Yeah, and access to lab data or variables may vary. So access to like mapping the particular iron content in a particular meal. That data, like we assume that the data is available. This is the timeline which we are keeping during the hackathon and post hackathon. So during the hackathon, we aim to basic UI brainstorming. So basically how the UI of the dashboard will look like, and interactive UI prototype. So UI, basically want to make the UI, which I'll be showing in the next slide, the mockup of the UI. And post hackathon, we want to actually complete this app and launch the nutritionist and doctor portal. So for the patient as well as for the doctor and caregiver, then we want to launch both these platforms which are integrated to the platform. And lab reports for personalized, so integrating lab reports whichever the patients have and recommending them diets, and expanding regional food database. So based on whichever state, whichever cuisines they have, whatever meals they have, we wanted to complete this database, building this database of food and recommendations and personalization engines. So this means that based on the mood that like the patient has, that the AI assistant should be like personal, like it gives them particular suggestions based on particular mood that that particular patient has. And implement start AI nudging, that is the same thing. So like responding in behavioral context, and yeah, conducting and partnering with NGOs. That is what we aim to do post the hackathon. And this is a dashboard which we have created this mockup, UI mockup. So what we aim to do is, for this food tracking part, add a meal. So enter the name of the food, the type, like morning, evening, breakfast, and dinner, and the portion size, iron content. This iron content later will be, getting it from the database. So the user might not have to enter the iron content of that particular meal. We just have to enter the name of the meal, and the iron content will be automatically, fetched from the database, and also the calories in that particular meal. And medications, you want to recommend the medications, like this is the recommendation part. This will be giving the notifications on their phone when the app is made. So like this particular medicine, take this, and then the patient marks it as taken. Then checking the mood of the patient, like how they feel, whether they're feeling happy, whether they're feeling sad, and like based on that will be, the assistant will be able to better recommend and better talk to the patient. And then water intake, like add a glass, meaning take how many water glasses the patient has taken, tracking that. And whatever the meal the patient has eaten, we are displaying the iron intake and the calories. Also, we'll be having the dashboard for the doctor or the caregiver, like a family member or a doctor, so that he can track whatever the intake of the patient is, the iron intake, the water intake, and also the mood of the particular patient, and whether he's taking medicines and all. So that platform will also be there. Thank you.